Hello everyone, welcome to the channel. We are solving question number 9 given in page number 69 of chapter 4 describing motion around us. Let us understand the question first. Question is, a car starts from rest, uniformly accelerate with a velocity of 20 meter per second in 5 seconds. It then travels at 20 meter per second for 10 seconds. And finally, the brakes are applied with uniform acceleration to stop in 6 seconds. Find the total distance traveled. So here you can see that it is about the motion of car. It start from rest. So this is we are talking about phase 1 because in different phases the motion of car is given. So in phase 1 it's initially at rest, so 0 meter per second, and it accelerates to a velocity of 20 meter per second. So it will be your final velocity, that is 20 meter per second, and it happens in a time of 5 second. So here we need to find the distance. We can just find the distance with the equation of motion. I am just writing second equation of motion, that is s equal to ut plus half at square. This is your second equation of motion. Here we need to find the acceleration also, because acceleration is not known. Acceleration is change in velocity, that is final velocity minus initial velocity upon time taken. So v is given 20 meter per second and your initial velocity is given 0 meter per second at time of 5 seconds. Now 20 minus 0, it is 20. 20 meter per second multiply with 1 upon 5 second. 5 1 ja, 5 4 ja. So it is 4 meter per second square. That will be the acceleration. Now with the help of acceleration we can just put the value here. So it will be like s will be equal to u is given as 0 meter per second multiply with time is given 5 second plus half a, acceleration is given 4 meter per second square, and it is t square, that is 5 second whole square. So it will be 0 plus half multiply with 4 meter per second square, 5 5 are 25 second square. Second square and second square cancel, 2 1 are 2, 2 2 are 4. So it will be 25 2 are 50 meter. So we have got that s value in the phase 1 as 50 meter. Now for phase 2, in phase 2 we can see that now that this car is traveling with the velocity of 20 meter per second and for a time of 10 second. This is what we need to find here, the distance also. We know that speed is equal to distance upon time. Now we can just find the distance here. Distance will be equal to speed, that is velocity, given as 20 meter per second, and multiply with time, that is 10 second. So it will be 200 meter. Second and second get cancelled. So the distance in the phase 2 covered by the car is 200 meter. Now they are saying that finally the brakes are applied to stop in 6 seconds. So for phase 3, in phase 3 you can see the initial velocity will be 20 meter per second and your final velocity will be 0 meter per second, because here in phase 3 brakes are applied. That's why the final velocity will be 0 meter per second and it has taken a time of 6 seconds. So here also we need to find the distance. So I can use another type of equation, which is your third equation of motion, v square minus u square equal to 2as. So here also we need to find s. I can just use s equal to v square minus u square upon 2a, but we need to find acceleration. Acceleration is change in velocity, v minus u upon t. V value is 0, 0 minus u value is 20. In bracket I can write down meter per second upon time is 6 second. So it is minus 20 upon 6 meter per second square. So that is your acceleration. Now I can just put the value here. What is v square? 0 square minus what is u square? 20 square. In bracket it will be meter square upon second square. I have taken common and I have done the squaring of that. Then time is then acceleration is 2 multiplied with a. A is given as minus 20 upon 6 meter per second square. So it will be 20 square is 400, so it is minus 400 divided by 22 ja 40, that is minus 40, so it will be 6 upon minus 40. As we are finding distance, definitely it will be meter here. Minus and minus get cancelled. 41 ja 40, 10 ja 10, 6 ja 60 meter. So here we have found the distance is 60 meter. So if I add all these three, the phases, in phase 1 the distance is 50 meter, in phase 2 the distance is 200 meter, and in phase 3 the distance is 60 meter. So if I add all the three, 200, 260, 310 meter. So 310 meter is the total distance traveled by the moving car. So this way we will solve this question. Hopefully you will understand.